Hello friends, welcome back. In this video we are going to study the rules of the IUPAC nomenclature of the coordination compounds. So let's study this IUPAC nomenclature of the coordination compounds. So we know that there are large number of coordination compounds are synthesized in day-to-day life. So to name such a large number of complexes, a systematic procedure is required. So the IUPAC, that is the International Union of Pure and Applied Chemistry, had framed some rules for naming these coordinated compounds. So let's start with the rules. Rules for naming the coordination compounds. So the first rule is for anionic compounds. Anionic compounds means the negative compounds or the complexes which are having the minus charge. So for anionic compounds, the cation is named first, followed by the full name of anion, and the name of these two, that is the cation and the anion, they are separated by a space. So let's take an example. So we are having this anionic compound. Why it is anionic compound? Because this square bracket, it indicates the complex. Outside this complex we are having this potassium. Potassium is the cation. It is positively charged. As it is positively charged, this complex having the negative charge. So this complex is known as the anionic complex, right? So here this K is the cation, whereas this Cn is the anion. Cation means positive charge, anion means the negative charge. So this cation is named as the potassium, whereas the anion is named as the hexacyano, which is the ligand. So according to the first rule, for the anionic complex, we have to first write the name of the cation, that is the potassium, then the name of the anion, that is the hexacyano, then we have to put the space. A space is there in between the cation and the anion. So this is the first example. Let's take one more example, that is a K2PtCl6. Again this K2, that is a potassium, is a cation, and this PtCl6, it is the anionic complex. It is having a negative charge. So this K is the cation, whereas the Cl is the anion. This cation is named as the potassium and the anion is named as the hexachloro. According to this first rule, we have to first write the name of the cation, that is the potassium, then the name of the anion, that is the hexachloro, then we have to keep a space between cation and the anion. So this is the first rule. Getting? Let us move on. We are having the second rule. So while writing the name of the complexes, the ligands, they are arranged alphabetically according to the, regardless of their charges. Okay. So while writing the names, we have to write the ligands alphabetically. We have to remember this only. Whereas while writing the formula of the complex, formula means the structure of the complex. So how to write the structure of the complex? The complex ion should be enclosed in a square bracket. We have seen in the example. Then the metal in the square bracket, we have to first put the metal. Metal is a name first. Then the coordinating groups, they are arranged. And they are coordinating groups means the ligands. They are arranged as, first of all, you have to put the negative ligands, then the neutral ligands, and then the positive ligands. And all they are arranged alphabetically according to the first symbol with each group. Right? That means we can say that we are having the metal, then the negative ligands, then the neutral ligands, and the positive ligands, and all they are placed in a square bracket. So this is why we have to write the formula or the structure of the complexes. So let us see the examples. First of all, for the negative ligands. Negative ligands means the name of the negative ligands ends with the letter O. So their examples are, so the various examples of the negative ligands which is having the ending O are. The first one is the Cn-. This Cn-, it is called as the negative ligand which is having the ending O, and it is named as the cyano. Cn- is the cyano. Next example, OH-. OH-, it is known as the hydroxo, which is having the O as the end. Then SO4-2-, it is known as the sulfato. Next is CO3-2-, which is carbonato. NH2-, that is imido. H- hydrido, N3 minus azido, NCS minus, that is isothiocyanato, O2 2 minus, that is peroxo, then Cl minus, that is chloro, NO2 minus nitro, C2O4 2 minus, that is oxalato, Br minus, that is bromo, SCN minus thiocyanato, ClO2 minus chlorito, SO3 2 minus sulfito, H2O3 2 minus thiosulfato, and ClO3 minus chlorato. So these are the various examples of the negative ligands which is having the special ending, that is the O. Let's move on. Next is the neutral ligands. So let us see the various examples of the neutral ligands. So these neutral ligands, they are named as a molecules without any special ending. So their examples are, the first one is the H2O. H2O, this is a neutral ligand and it is named as the aquo. Py, that is the pyridine. NH3, that is the amine. ONO, that is nitrito. NO, that is a nitrosyl. NH, that is imido. CO, that is carbonyl. NH2, that is amido. So these are the various examples of the neutral ligands. Then we are having the positive ligands. So the positive ligands, the name of the positive ligands, they ends with dash IUM. Okay. So their examples of the positive ligands. The first one is the NO plus, which is named as the nitronium, whereas the second one is the NH2 NH3 plus, which is known as the hydrazinium. So these two are the examples of the positive ligands. So further we have seen that while writing the structure of the complex, we have to put the metals and the ligands in the square bracket, right? And then the ligand, that is the coordinating groups, they are arranged alphabetically. So let's see this. So we are having the metals and the ligands, they are arranged in a square brackets, right? Then the metals, they are generally transition metals such as chromium, iron, cobalt, OH, that is osmium, platinum, zinc, etc. So these are the examples of the transition metals. So after metals we have to put the ligands. Ligands, they are the negative ligands, neutral ligands and the positive ligands. So first of all we are having, yes, the anionic, that is the negative ligands. So the negative ligands, their examples are the CN, that is cyanide, EDTA, F minus, NO2, OX, etc. So we have to put this negative ligand alphabetically. Then the second ligand, the second type of the ligands we have to put, they are the neutral ligands. What are the examples of the neutral ligands? They are the CO, that is a carbonyl, EN, H2O, NH3, etc. So we have to put the neutral ligands again alphabetically. And then the remaining third type of the ligands, they are the positive ligands. Positive ligands means the cationic ligands, and their examples are the NO plus, NH2, NH3 plus, etc. Again we have to put them alphabetically, right? So in the square bracket we have to put first of all metals and then the ligands. The ligands are the positive ligands, negative ligands, neutral ligands and the positive ligands. Then outside the square bracket we have to put a charge, right? And the charge is the plus and the minus charge. So this is regarding when we have to put a formula or when we have to draw the structure of the complex. Okay. Then further, the third IUPAC rule is the naming of prefixes. So for simple ligands, that means the monodentate ligands, the number of each ligand is given by the prefixes such as the di for the 2 ligands, tri for the 3 ligands, tetra for the 4 ligands, etc. Right? While for the multidentate ligands, the prefixes such as bis for 2, tris for 3, tetrakis for the 4, pentakis for the 5, they are used and the group is placed in the bracket, right? So let us take an example. Example is the COEN twice Cl2 Cl. Okay, here now we are having the two types of the ligands. Cl is the monodentate ligands, whereas the En is the polydentate, or we can say the multidentate ligands. Then this Cn is the polydentate ligand and this is the monodentate ligand. So while writing the name, what we can write? It is named as the dichloro. Dichlor because it is a negative ligand. Negatively monodentate is the negative ligand and this En is the neutral ligand. So it is a dichloro bis. Bis, it is a multidentate, therefore it is for 2. We are writing bis ethylene diamine. Okay. So this is the third rule, which is called as the naming of prefixes. Then the fourth rule, that is the oxidation number or the oxidation state. So the oxidation number of the central metal atom or the ion is shown by the Roman number such as 1, 2, 3 or the 4, and it is put in a bracket at the end of the name of the complex without any space between the two. So let us take an example. Example is a NaCO4. Now we can say that for the name it is sodium for the cation, then tetracarbonyl, this is for the second ligand, and in between these two we are having a space, and the oxidation number of the cobalt is 1, therefore at the end we have to put the 1 in a Roman, and that is in the square in the bracket without any space. Then rule number 5 is the anionic complex ion. In the first rule we have seen the cationic. Now next is the anionic complex ion. So if a complex part is the negative ion, then the positive ion is written first. We have seen in the first rule. Then the name of the central metal ends with -ate. Okay, that means this is the extension of the first rule. So let us see the same example as NaCO4. So for this example, the name will be sodium tetracarbonyl. The metal is cobalt and it is having a special ending, that is -ate. Therefore it is cobaltate 1, right? So this is the rule which is used for the anionic complex ion. Anionic complex ion means on the square bracket it is having a minus charge. Then rule number 6, cationic or the neutral complexes. That means the positive or the neutral complexes. So in case of the cationic or the neutral complexes, the metal name is used without any characteristics ending. In case of the earlier we have seen there is a characteristic ending, that is -ate, whereas in this case there is no special characteristic ending. So its example is CONH3,3Cl3. So how it is named? It is a name as trichlorotriamine cobalt plus 3. In case of this metal do not have any special ending because it is a neutral complex. Okay, this is rule number 6. Rule number 7, bridging ligands. Bridging means the same ligand is attached to the two metals. So if a complex contains 2 or more metal atoms, that is a polynuclear complex, then the ligand which link to 2 metals are called as the bridging ligands. And these bridging ligands, they are indicated by placing a symbol mu before its name. So if there are 2 or more bridging groups are present, they are indicated as di-mu for 2 bridging ligands, tri-mu for 3 bridging ligands, etc. So let us see the example. Its example is, this is the example. Now in this example we can see that this NH2 and NO2, they are attached to 2 metal, that is a cobalt. Therefore this NH2 and the NO2, they are known as the bridging ligands, and while placing their name we have to use mu, right? So its name is, it is a name as mu amido. For NH2 we have to write the amido, for NO2 we have to write the nitro. So it is mu amido, mu nitro, octaamine. Octa means 8 amine. This 4 plus 4. There are 8 amine, therefore it is octaamine. Then 2 cobalt, therefore dicobalt. Oxidation state is the +3 and outside the square bracket nitrate. So it is a mu means bridging, mu amido, mu nitro, octaamine, dicobalt +3 nitrate. So this is rule number 7. Rule number 8, geometrical isomers. Geometrical means the cis-trans isomerism. So they are indicated or designated by using cis and the trans basic notation. Cis means the same side groups, they are towards the same side. Same groups are towards the same side. And trans means same groups are towards the opposite side. So its example is PT, which is attached to NH2, NH3, NH3, ClBr. And the same example. Now in this example, the similar group is this NH3 group, right? In the first case, this NH3 is towards the same side. In the second case, the NH3, they are towards the opposite side. So the first one is known as cis isomer and the second one is known as the trans isomer. Why the first one is cis? Because the NH3, first NH3 and the second NH3, they are towards the same side. So as the similar groups are at the adjacent position, it is known as the cis isomer. Whereas in the second case, the NH3 and the NH3, that means the similar groups, they are towards the opposite side. So similar groups at the opposite position, that's why it is called as the trans isomer. So these are the geometrical isomers. Rule number 9, that is the optical isomers. Optical isomers means the D and L isomers. So they are designated by using the symbols or the letter D, or we have to use the positive sign, plus sign, or a letter L or the negative signs. So their examples are, this is the first example, that is CO, Cl, Cl, ethylene diamine, that is En. This is known as the cis D isomer. And the second one, the same structure, we are having the ethylene diamine, Cl, Cl, they are towards the opposite side. It is called as a cis L isomer. So the first one is called as the D isomer and the second one is called as the L isomer. Both are the cis isomer. Only the first one is the D and the second one is the L, and they are known as the optical isomers. Rule number 10, that is the point of attachment. So sometimes a ligand may be attached to different atoms. We can say that this MnO2, here this M is the metal and NO2 is the ligand. Here it is called as the nitro. Similarly, we are having the same, that is MONO. Here also we are having the NO2 group, but this metal is attached through oxygen. In the earlier case, the metal is attached to nitrogen, right? Similarly, we are having the MSCN, which is called as the thiocyanato. Similarly, this is also called as the thiocyanato S, because metal is attached to S. Also, we are having the MNCS, the same, but it is called as the isothiocyanato, or it is also named as the thiocyanato N. Why? Because this metal is attached to nitrogen. So we can say that the ligand, the same ligands, it is attached through different atoms. So its example is NH3,4 thioCrSCN. So it is a name as ammonium hexathiocyanato N. Ammonium hexathiocyanato N chromate plus 3. Here it is 6, right? In case of the SCN, it is 6 over here. So it is a name as ammonium hexathiocyanato N chromate plus 3. So this is point of attachment. Next rule, solvent of crystallization. If any water or the solvent of crystallization are present, they follow the name and are preceded by the number of these groups in the Arabic numericals. And the last one, abbreviations. Some ligands possesses long and complicated names, right? So while naming such ligand, their short forms are used in the formula. Its examples are En, that is ethylene diamine, Pn, Py, that is pyridine, etc. So these are the rules of the IUPAC nomenclature which are used in the coordination compounds, and by using these rules we have to study the various examples of the coordination compounds. Thank you.